Hi guys, and welcome to Intro to Clinical Neurology 101. My name is, there's my finger, sorry about that. My name is Shane, and I also go by Light Rays. And I will be guiding you through this fantastical tour of the nervous system throughout this year. Hand. Alright, so what we have here today is just a basic outline of the brain, and primarily this is intended to show you typically the first 6 or 7 structures that you'd want to learn, that you want to draw out. Say you were just drawing a little outline of the brain, and you want to know your basic lobes, hemispheres, things like that. So that's what I've drawn out for you today. So we're just going to get right to it. So right here I've sectioned it off into 2 well-defined pieces. First, right here we have our little square, and this right here, that's the medulla oblongata. That is that long, there we go. And up here, that is the pons, and this is collectively known as the brainstem. And then we have here the cerebellum, and that's known as the little brain, or the tiny cerebrum as I call it. So essentially we have this big helmet that sits up here, and then we have this little square that sits down there. So this whole helmet shape right there, that is called the cerebrum. And when you refer to the lobes of the brain, typically you refer to them as the lobes of the cerebrum, or the lobes of the cerebral cortex. And that is all of this little helmet part right here. And even including everything is that little swirly spiral. So I'm just going to go through the basic lobes of the brain, and you'll notice here that I have drawn a little cross section of a brain, and I've organized the temporal and parietal lobes in a way that they look like they're beside one another. And the reason why I've done that is because a lot of people can't remember which way it's oriented and which way the temporal and parietal lobes are actually situated. So here you just want to pretend that the brain is looked at as a cross section from up above in a non-radiograph orient, which means it's head on. You have the occipital lobe, bottom, frontal lobe, top, temporal is left, parietal is right. I don't really have any way to remember that. Just parietal right, temporal left. And occipital is low and frontal is high. So we go to our frontal lobe, which is here in a little cross section, and we will go right over to our diagram, and that is the frontal lobe right there. So that's this big part right here. It's one of the bigger ones. And then we go to the back, occipital, and the occipital lobe is in the back. So right now we're not really going through a whole lot of what definitions they are, what functions they serve, but I'll just go into a little bit of detail just so you know we're not talking about random nonsense. The frontal lobe is usually associated with decision making, motivation, reward, pleasure, things like that. So it's typically seen as the driving center of your personality, pretty much. When you make a decision, when you take an action, when you make a voluntary choice, usually you're using that frontal cortex. When you say, oh, I really want to buy that, I'm going to buy that right now, and you're using that impulse, that's the frontal cortex saying, nah, I'm just not going to bother inhibiting that today. So anyway, the occipital lobe is vision, all vision, color vision, visual perception, spatial perception, orientation, everything like that. That is the occipital lobe, and that is in the back of the brain. And the way that I typically advise my students to remember that is that when you see an image in your eyes, usually it goes to the back of your eye. So if it goes to the back of your eye, it goes to the back of your brain. So the occipital lobe, automatically you want to go straight in the back of your brain. So you got frontal, occipital. Now we do left, right. So the the temporal lobe is actually under the parietal lobe. When we see here on our little diagram here, it's actually under it. So we have this little helmet here, and then this is kind of underneath it. If you want to see a cross section that I'll show you on our site once we start going into the assignments, you'll actually begin to see through the actual cross sections of the brain how it is actually underneath. So it's not laid out like this, like you think. It's actually directly below the parietal lobe. So the temporal lobe with the temporal is right here, and we want to see this block. And that is usually associated with our primary auditory cortex, as well as it is useful to derive meaning, intrinsic understanding of qualia, describe the color red, what does a strawberry taste like without comparing it to another food, you know, what's the meaning of life, you know, is Jesus real, you know, things like that, you know, is religion real, what's my purpose, does God love me, things like that, where we really go into the mystical and the unusual. Usually that's a result of a firing happening in the temporal lobe, and usually you'll see that with complex partial seizures where patients will demonstrate delusions and hallucinations, delusions of grandeur, things like that. That's where they'll originate usually. So that is the temporal lobe, and then right above it we have the parietal lobe, and here parietal lobe is on the right, and in our little diagram it's on the right. So that is the parietal lobe, but as we know, that's actually on top. And the parietal lobe is balance, visual spatial perception, spatial orientation, proprioception, nociception, mechanoperception, touch discrimination, things like that. So I'm going to get into a whole lot more detail about all of this once we go on to our further lessons, but for now that'll just be a suffice as a basic. So I also drew, as you can see, these little squigglies in here, just because this is typically what you will see on a brain diagram. Even if you're not looking for it, it'll just always show up the little squigglies. So the outside squiggly here, that is called the corpus callosum, and that is a bridge between the two halves of your brain. So as you know, you have the right and left side of your brain. That is mediated by the corpus callosum. So if you didn't have that, we actually wouldn't really, you know, we can actually see patients who've had status epilepticus who have had that bridge severed so that the halves of the brain can learn to interact independently, and often they'll struggle with getting dressed, eating, feeding themselves, because both sides of their body will do two separate things at the same time. So there's that. So that's the corpus callosum. And then we have here this little cluster, the first cluster, that's the hypothalamus, that's temperature regulation, circadian rhythm, light-dark perception. Then we have the amygdala, emotions, emotional intelligence, empathy, anger, stress, blah, blah. I'm sure you've heard of the amygdala. And then over there we have the hippocampus, memory and learning. So if you want to just hippocampus, amygdala, hypothalamus. So that's just a little triangle right there. So, and here we have the motor and sensory afferent pathways that begin to form right around there. And just as an aside, just, you know, to kind of bridge this whole thing, just because this is, again, a very brief overview before we get started on our course later on this month. So the calvarium, that's the skull cap. I drew some little hairs popping off of it. So if you just want to imagine that this whole thing is kind of pasted over the brain. So, you know, this is your brain, it's inside your skull, and these little fibers, lines are separating it. So the first is the dura mater, and that is pronounced mater. It's Latin for strong mother, so it's not pronounced matter. And that is the first layer right below the calvarium, that's the dura mater, and then we have the subdural cavity below that, and then we have the subarachnoid cavity. So that would be where you might hear somebody who's had a subarachnoid hemorrhage. What would happen is that blood from the brain actually goes up into the subarachnoid cavity and causes it to expand, but because the calvarium and the cranium are so dense, it doesn't balloon up, it balloons back into the brain, and that is what causes the swelling and pressure on the brain, and that's what causes your brain damage. So essentially, that's what I have so far here. And I just want to welcome you guys to Intro to Clinical Neurology, and I really hope we're going to have a fantastic year.